All right, so today we are looking at both the law of sines and cosines and some applications. So in this first problem, they give us the picture of the situation, and we notice that we're going to use the law of sines because we do have an angle opposite side match. However, ultimately we have to use the inverse sine to get this angle measure. Now this is an ambiguous case because we're given an angle and two sides, but we know that we do not have to check for another possible solution because unlike the problems we did yesterday, this problem tells us that that angle y is an obtuse angle, and we know we cannot have more than one obtuse angle in a triangle in our Euclidean geometry. The second one, we have to come up with a picture and label it and then go from there. So when I see something due east, due west, I put in my north, south, east, west compass here. And then I put B due east. That means from horizontal to the right of A, 20 miles apart. My angle of elevation is 40 degrees. My angle of elevation is 54. The other thing I do so that I don't associate the value of A with how far A is from the fire is I go ahead and set up my little answer responses, making sure I put the correct leg of the triangle or correct side of the triangle underneath what I'm going to fill in. And then I use my law of sines because I do have a match because I have two of the three angles in the triangle. I can quickly get the third. So here are my two proportions. I solve them for A and B and I get these distances. Number 3 also requires us to draw a picture. And I've got the vertex of my triangle at the station, the tracks going either direction, like opposite directions. And instead of giving us a distance, they're giving us a rate at which the two trains are traveling, which means we have to take that rate times the length of travel to get the distance the two trains are after 2 hours. And this is a law of cosines problem because I do not have any angle opposite side match. Now, something a little bit different from law of sines and cosines. These are two alternate ways to find the area of an oblique triangle. And the first one basically uses two sides and an included angle along with this formula. So if we give it a try, we have sides of 24 and 10 meters respectively with an included angle. That means the angle in between is 62 degrees. I just plug it into the formula and I get 106 square meters. Okay, our last way to calculate the area of an oblique triangle is to use something called Huron's formula. And it involves something new called the semi-perimeter, which is all the sides added up, the three sides, divided by 2. And we don't have a 1/2 in this formula, and we don't have 3 components being multiplied together like the other one. We have 4 things multiplied underneath the square root, the semi-perimeter, and the difference between each side and the semi-perimeter. So if we try it out on this one, they're asking for the exact area, so we're going to have to extract roots like we did earlier in the school year. This is a nice little refresher. I find my semi-perimeter, and then I have semi-perimeter minus side 1, minus side 2, minus side 3. I have a 23, an 8, a 10, and a 5. I've got 23 as a prime number. I rethink 8 or 10 as 2 and 5, 8 as 2 and 4, and then I just copy down 5, that's prime. But I notice I have 2 5s, one of which can come out. Square root of 4 is 2, 2 2's, one of which can come out. So the exact answer is 20 square root 23 millimeters squared. If we just typed it all into our calculator, we get an approximate value of 95.9 millimeters squared. Okay, the rest are for you to try, so you can pause the video, try one, and then check it. how you're feeling about this lesson and the law of sine and cosines in general. If you need some help, schedule yourself or ask me to schedule you for Compass.